I'm going to show more advanced examples. And as Mo has already introduced the basic features of MXNet, and I'm going to do something that's related to real-world deep learning. And you have tried synthetic examples, and let's now try on some real toy examples. If you have ever done deep learning before, or machine learning before, the must-try data set is the handwritten digit data set, which is a quick demonstration of how you can apply MXNet on the general convolution neural network framework. So this is a tutorial on advanced convolution neural network example. We can start by importing MXNet as usual. And here we are declaring two-layer fully connected neural networks, which actually we did that before in the last tutorial on the symbolic layers. And you can find that we can list arguments of a neural net so that each of the variables contains exactly one argument. What we can do is that we can utilize scikit-learn. One great idea of MXNet is that we want to be able to combine the total infrastructure together with all the existing ecosystems. So if you use Python, it works together with scikit-learn and all the existing ecosystems. If you use R, it works with data frames and all the other systems you can have. So here we can show some type of digits that you can have that you can fetch from the original MX data set. These are handwritten digits, but we use handwritten digits because they are easy to demonstrate in a minute. But if you want to have more time, you can definitely go and try more complicated examples. We can pack these ND arrays into an ND array iterator and use the model API. This is a very high-level API that basically allows you to define a network structure, put it into a feed-forward network, and call fit function to fit it. And as Mo mentioned, that we can simply change the context list from GPU to list of GPU 1, 2, 3 if you have multiple of them. So only one line of change from single GPU to multiple GPU experiment. And it usually gives you a better speed up if you have a complicated workload, which we all do on deep learning. Now we are doing something interesting in the sense that we can get a random image and predict what the prediction is. And we can see that predicted results is exactly 7 as it showed on the graph. And we can evaluate the test accuracy on this two-layer neural network on the MX data set. Well, this is OK, and let's do something more fun. So here, what we are doing is that we are actually embedding a handwritten pad on a Python notebook and classify the digits that are right here on HTML file. You click classify, and it's a small app that allows you to classify digits, and you can build other interesting apps that you can use them to classify other things like images. And I can try something more weird, maybe. OK, it's still a 2. And this is only a few lines code that allows you to combine Python, IPython notebook, and actually part of JavaScript together. So actually, we're going quick here. So besides these normal features of configuring and training convolution neural networks, you can also sometimes you don't perfectly define a neural network. You want to have some ways to debugging and look into what's going on when you have a neural net when you define that network structure. On that end, you can define a monitor structure that allows you to look into what is the norm of each of the weight and gradients within the neural network training, so that you can watch the weights norm as they go, and if something wrong happens, you can find it and directly fix them on the fly. I think I will skip this one, and Mo already talked about the operators. OK, so we have talked about the example about classifying digits, and now let's try an example on classifying real-world images. I'm going to this is a link at OK. This is MXNet JavaScript package, which means all of you can go to a link and you can directly click on it to find what you need. We have a more advanced version here. Actually, let me try the basic version. So what it does is it's okay. The old link does not work. Let's see the link. Yeah, what it does is that it's a in-browser JavaScript library that allows you to directly run a prediction in the browser on your machine instead of servers. So this is an interesting advantage of MXNet in a sense that MXNet comes with very little dependencies so that you can easily embed the entire system into mobile phones, web browsers, which is harder for other libraries to do because they have a lot of dependencies. And we can find some interesting images. Usually, I can Google cat image. I think we have something on the, okay. Trumpy cat. I think we do have some backup cat images on MXNet's repo. Okay, it should be in web data. Image and I guess I would just get some random cat images from the web. Oops. Where's URL? Do you know if you have an image on the around? Huh?
So the new Mac is not so easy to get.
Yeah.
Oops. Well.
No, copy that to local. That's also okay. If you
Well, how to get the URL link?
Right click.
Well.
I don't think we have some on a repo. If that's
I need to say I cannot get the.
okay.
I never figure out how to use the.
Yeah. Let me just get something from repo. Yeah.
Oh, sorry about that.
Yeah. Yeah, maybe I can do a screen copy. But I do think we have something on a. Anyway, so yeah, we can upload. Do we have any files locally?
No, we can save this file.
That's it. Image file, not URL.
Oh.
So all these things happens in the browser in a sense that it might run slower than the GPU version or server-based version, but instead what it runs it directly uploads the image and actually it doesn't upload to any server, but directly loads the image into a JavaScript library and runs the classification on the JavaScript library on user's browser. And this is an interesting tool for demonstrations for, in a sense that if you want to do any demo about deep learning or any models that you're training on Python, it's likely that you can directly use this JavaScript library to directly demo the classification capability. So here it gets the image and it predicts that it's a tiger, and all the things runs on the browser. Okay. So now we have go through the basic classification demo. Let's also try other demos. Okay. Yes. This is a demo of automatic conversion of 2D images to 3D images, and it's very useful for it's very useful in the cases when you want to do like virtual reality thing. So this is a fully convolutional neural network that allows you to directly load in a 2D image and generate 2 eyes version that you can see from the 3D glasses. So what it does is that it basically loads in a pre-trained model that's trained on the GPU. Okay, let's see. Failed load. Okay. Yeah, I guess we'll just skip this one because there's something broken here. I will try another one. Okay. This is a demo on advanced use cases of MXNet on the full recipe of recurrent neural networks. As you all know, that recurrent neural networks is the basic building blocks for the language modeling and the other type of tasks like image captioning and caption generations. And the basic composition module of LSTM is built on top of several blocks, including it builds on 3 types of cells, including a basic memory cell and the activation cell. The idea is that we will keep a memory cell always in cap so that it remembers the state from history while it reads the input and updates the memory cell on the fly, so that it can reflect the entire history of the program while emitting another sequences. So what we do here is that we can define a auxiliary data structure called LSTM state that combines the hidden state and activation state of LSTM. Then we can use a Python program, which is that defines the entire LSTM cell, and here is the more illustrative figure on how LSTM cell looks like. Basically, a LSTM unit can take an input from a previous state, generate some output, and feed that back to the LSTM cell, so that over time it will remember the entire history of the state and try to emit the outputs. By training the entire LSTM together in an unrolled fashion, we can unroll this LSTM over timestamps, so that this entire unload graph can be trained using backpropagation in an end-to-end fashion. And here in this function, what we define is the LSTM unit, is the LSTM cell that you can find that given the input state, it will first apply a fully connect layer to transform that input state to a hidden state, and it will also apply another fully connect layer to transform the previous state to an input state. Then these 2 states are added together, and pass through several activation functions. One of the important update formula of LSTM is actually this line, that will multiplies activation by a forgotten rate, and plus the transformation, so that it's a combined. Yeah. You want to zoom in? Okay, I get that. So that the next state is a combination of a scale transformation of previous state plus the transformation of the input state. Finally, the output is fed by an activation function multiplies the output gate's activation. After we define the LSTM cells, we can use, okay. I think I need to zoom back. We can use this. We can define an entire function to unroll the entire LSTM sequence together, in a sense that this is the basic building blocks of deep learning. In a sense, you first build small building blocks like LSTM cell, then you combine different LSTMs together and unroll it over time. So after we do that, then we can feed it into an unrolling function to get the generated LSTM cells. After we get symbols, we can bind all these symbols to a model list, like we do for the convolutional neural network, except that now it's a sequence model over time. So when, okay. One of the important things in the sequence execution is that the input sequence may not be restricted to a single length, in a sense that there could be multiple different lengths of input execution. And in order to solve that, we will provide a bucketing execution example that allows us to bucket the different type of inputs into different buckets. And this can be used using the module API that automatically buckets inputs in this. And then you can pass the input into these buckets. Let's see. Yeah, then you can pass this into the buckets and generate output sequence. So by putting it all together, you can train it using the fitting function later and get an entire sequence to sequence training. Okay. And if you are around, we have more examples on character-based LSTMs and neural art examples that you can play around on the hands-on tutorials. And we'll be happy to answer any questions that you might have. Okay. Yeah. Mm-hmm. You want to first follow the command to open the. So if you want to get the terminal.
Let me show how to get it on. So basically, this is some tutorial we did for the GTC on the April this year. So all this code on the DMC MXNet -GTC tutorial. So it's not default on the machine we have. So I'm going to show how to get this one to running. So if you click the Jupyter here, you will get the Jupyter main page. Let me try a different. This already have. So then, well, well. So basically, the basic idea that we try new here. You can create a new Python notebook. Okay, you can create a terminal. So you can run this thing on Python, it's fine. The easy way that you go to terminal, this is actually SSH to that particular machine. So for example, you can show this particular machine have a GPU there. The next thing, you just put this git clone this tutorial into their machine, will do the job. So if you copy this line, well, where's my terminal? Oh, here. So I already have that one. Let's remove it. So you just git clone to download this link into the home directory. This is a root account. Then I take 1 minute to get it. Well, So then it's there. So you can follow the link to click anything you have. So basically, you can see that this is this is generated by the IPython notebook. This is just the file direct path of the particular thing you put on the home directory. So then you can maybe try the new art name. So.
It's a changing error. What? Maybe it's because the data is no longer there.
Because this is because
the VGG data, right?
no, it's here. Oh, we've done the Python or Inter. So the easy way that you just go to well, I think the model is there. Oh. Well, basically, let me finish during night. We are going to put all these tutorials notebook into. This is already let's make half years ago. We didn't maintain that well. In the future, all this document. So if you look at, if you want to see more documents, the first place is go to MXNet.dmc.ml. So if you use different packages, for example, R, I think we have R document.
Yes.
So if you go to R, you maybe have try the R documents. Also, we are going to put all this notebook, for example, tutorials into MXNet-notebooks. So today's notebook is already there in the Python. All this recommendation, RN, CN, basic. So for example, the tutorial I run here, you can click on the GitHub. It's already there. So the next thing we are finishing maybe in a few days to move all these tutorials into this repo and to have instructions if you want to run on local. If you just want to look at it, it's fine, totally fine, because all this result is nice rendered in GitHub. But if you want to try the thing, we're going to move it here. In the future, I think notebook is one of the future to share doc, and we are document doc. So we are probably want to invest a lot of efforts on the notebook. Also, we will have very big news to announce maybe next month. I cannot tell what it is. So if this is small, you will have more reasons why you want to use MXNet compared to TensorFlow or other things. So just 1 month, I cannot allow to say at this moment. Also, I think we're going to, on the next, so in the past year, we already, if you look at the MXNet repo, we just start Tianqi and me and a bunch of guys. We just meet at the GitHub. Start MXNet in the 1 year ago actually. Just 1 year ago. This is the current state we have. On the past years, we did a lot of things to the backend engine to optimize to make it fast, to make it memory efficient, to make the distributed training much faster. We also so we just within a year we did a very large community size. So this is a commit we have, and this we have already pulled the 1,000 of pull requests. This is how developers submit code into MXNet. I think we did a good job on the system optimization and also some very fancy technology here. In the next half year, I think we're going to make the document much better. This is not, we pay too many attention to make more tutorials, make the thing more stable, and we want to run more smoothly on the cloud or even on the local systems. So currently, you maybe, if we want to use it, you still need to be hands-on there. So, but in the few months, we are quite improved the usability here. So also give more document to different language. So I think.
Yeah. So I think that would be the end of the end of the interactive session that we will give in talks. And if you'd like to stick around, we'll be happy to answer questions. The MOC is a community that we build to maintain the open source software, and you might hear some of them, including MXNet and XGBoost, that we use to support a wide range of data science problems. And the general idea is that we want to build an entire stack for the machine learning and data scientists on different languages. So you can choose your language like R and Scala. And there are other interesting tutorials that you can run. For example, we have a deep learning tutorial for recommender assistants that's actually presenting at the KDD, and they have a full notebook that you can play with on the hands-on link. Yeah. So thanks very much for attending this hands-on.